Welcome back, smart mathematicians. Let's do question 4.2.3. In the diagram, the circle centered at N passes through point A and C. B, C, D, and E are joined to form a parallelogram such that BE is parallel to the x-axis, and then CD is a tangent to the circle at C, and CD is equal to 6 units. Calculate the area of triangle triangle BCD. So this is the triangle here that we want to find its area, and then if we check, it is half of what? Of parallelogram BCDE. So if we can find the area of the parallelogram and then we half it, or we divide it by 2, then we're going to find the area of triangle BCD. Right, how do we find the area of a parallelogram? Do you remember that? Area of parallelogram is equal to base. Okay, our base can be CD there because we have the length of CD there, base times the perpendicular height. Okay, and then the perpendicular height is going to be this height here. Remember, this is CD is the tangent, so it is perpendicular to the radius. So we have to find the distance of this perpendicular height. Okay, this is 3, this is 2 here, so it means this is 1 unit. 1 unit. And then remember from the previous question, you know that Cn is 4 units. Okay, so it means the perpendicular height is 5 units. You see that? So what would be the area of triangle BCD? Then area of triangle BCD is going to be half of what? Of the area of parallelogram. Okay, so it's going to be half times 6 times 5. Okay, which is equal to 15 square units. Okay, so that's the answer there. So the other method we can use is that we can find the angle of inclination of BC. The angle of inclination of BC. What is the gradient of BC? Change in y over change in x. So this one here, we said, what would be this point here? This one here. Right. X is -1. Then what about y? Y is 2, isn't it? Because this BE is what? Is horizontal. Okay. -1 from CN there, the vertical line. And remember, we have the coordinates of C, which is -1 and 7. Okay, remember that. So the gradient of BC. Okay, let's find the gradient of BC. So MBC is equal to change in y. So it's going to be the y coordinate of C minus the y coordinate of B there. So it's going to be 7 minus 2 over the x coordinate of C minus the x coordinate of B, which is -1 minus -4, right, which is 5 over -1 plus 4 is 3, so which is 5 over 3. So now we can find the angle of inclination of BC. So we say that M is equal to tan theta. Then we say 5 over 3 is equal to tan theta. And then theta, we find arctan of 5 over 3. So you can use your calculator, you'll find that theta is equal to 59,036. It goes on like that, okay? It's a non-recurring, non-terminating decimal. Right, and then this is the angle of inclination here, which is 59,036 degrees. Right, which is equal to this angle here. Remember we said BE is parallel to the x-axis. So these are corresponding angles. So this is also 59,036 degrees. Okay, right. So we can say, let's find this angle here. Okay, why are we doing all this? If we find this angle here, we have side CD, we can find distance BC. Okay, I should have explained this before we started. Right, we have side BCD, and then you can find side BC. If you check, you are going to have two sides and an included angle. And then we can use the area rule to find the area of this triangle BCD. Okay, right. So now we found this angle here, which is 59,036, and then this angle, okay, let's say CBE plus angle BCD. This should be equal to 180 degrees because they are co-interior angles. Okay, right. So saying 59,036 degrees plus BCD is equal to 180 degrees. Then angle BCD is equal to 180 degrees minus 59,036 degrees. And then we get that angle BCD is equal to 120,96 degrees. So this angle here is 120,96 degrees. Okay, right. Now we can find the side BC, and then after finding side BC, then we can use our area rule. Okay, let's find BC. Right, BC, the length BC is equal to, let's start with B, so it's going to be square root of, then we say -4 minus -1. -4 minus -1 squared plus 2 minus 7 squared. Okay, so BC is equal to, right, -4 plus 1, this is -3, -3 squared, that is 9, plus 2 minus 7, that is 5, -5 squared, that is 25. So it becomes BC is equal to the square root of 34. Okay, and then now we have our BC and our CD and the included angle. We can use our sine rule. So therefore, area triangle BCD is equal to, we use our area rule, which is going to be half times BC times CD, then sine C, okay, which is angle BCD there. And then so therefore it's going to be half times square root of 34 times 6 times sine 120,96 degrees. Then put this in the calculator, which will be 15,00 something, which is roughly 15 units squared. Okay, that's another way of finding the area of what? Of triangle BCD. Okay, right. We'll meet when you do question 431.